Hello everyone, and welcome back to our discussion about properties of trigonometric functions. Last time we discussed two properties before, which were number one, interchanging of sine and cosine, and even and odd trigonometric functions. Now, this would be the last property that we're going to discuss, and we're going to continue the other properties. Remember that in our previous video, that I mentioned that there are actually a lot of properties. Although I'm just gonna pick only three because the rest are actually for the graph of a trigonometric function. So in other words, those properties that we're not going to discuss involves graphing. So we're going to talk about that soon. Okay? So without further ado, let's now begin. So our property that we're going to discuss today is what we call as the periodic property of trigonometric function. So let's have a short recall about getting the coterminal angle. So remember that in getting the coterminal angle, we either add or subtract the given angle by 360 degrees. Okay? So for example, let's just say in this first revolution, or in a whole revolution, remember that uh, if we are going to start here and we're going to rotate or revolve, we always start at 0 degrees. Then going further, if we're going to rotate at counterclockwise, okay, going further, once you reach here, we will have 90 degrees. Going further here, we will have 180 degrees. Going down to 170 degrees and reaching one whole revolution will give you 360 degrees. So here, suppose that we have an angle, let's just say 30 degrees. Okay? So from here up to there, you form an angle of 30 degrees. Wait, I'm just gonna get a calculator. Right, good. So now what we're going to do is we will get its coterminal angle. So we either add or subtract that given angle by 360 degrees. So that means if I'm going to get the angle of coterminal angle of 30 degrees, then what I can do is I can just add 360 degrees. So what happens is that if you're going to add 360 degrees, it seems like you're going to revolve here. Then the angle here in which you're going to find it by adding 30 degrees by, sorry, this 360, by 360 degrees, you will have 390 degrees. Okay, so that means initially it's 30 degrees, then after one revolution, the angle here would be 390 degrees. Okay, and as you can see, 390 degrees is actually on second revolution, which is here. Okay, in the second revolution, okay, assumingly that we always starts on the right side and we're going to rotate counterclockwise, we start at 360 degrees. Then going further, we will have 45 degrees or 450 degrees. Going here, we will have 540 degrees. Here we will have 630 degrees. And here we will have 720 degrees for complete two revolutions. So, as you can see, 390 degrees is actually located in between 450 and 360. So that means this is 390 degrees. In fact, since they are coterminal angles, that means they are in the same position. They may be equivalent, but they're not actually the same in terms of their number. But they are equivalent because of their position. Okay? So as we get the coterminal angle, we notice that we found a number for revolution. So right, we get 30 degrees, right? So sorry, we have 30 degrees as a given angle. Then we get 390 degrees by adding 30 by 360. As a result, you have 390 degrees, in which that is the coterminal angle. In fact, 390 degrees, once again, is located on the second revolution, which is here. So that means if we want to find the coterminal angle of an angle or of a given angle, then the thing is we can actually find the number of revolution it takes for it to find. So just like this, for instance, we have 30 degrees, then 390 degrees. For us to achieve 390 degrees, all we need to do is add 360 degrees. And as you can see, we've reached second revolution. Therefore, to get 390 degrees, you need two revolutions, right? So yeah, that's basically like a brief summary about coterminal angles. All right. If you need to learn more about it, I actually uploaded videos about coterminal angles. I suggest you should watch that. Okay. Don't worry. I will put it on the description. So why are we going to relate coterminal angles in this case? Okay. Now let's try to find the the value of a sine with this angle only. Okay? With this angle only. So we have sine of, let's start with 30 degrees. What would be our answer here? Sine of 30 degrees is actually 1/2, right? And let's just say we have sine of 390 degrees. If you're going to use your calculator, the answer here is still 1/2. So you see, not only that these angles are coterminal to each other, but both of them have the same answer, right? So let's try another one. Suppose I have sine 50 degrees. Let's just say I have sine 50 degrees. Okay? Then let's just say that I will add 50 degrees by 360 degrees so that I can get its coterminal angle. So 50 plus 360, we will have 410 degrees. Okay. Now, what we're going to do is we will get their value. Okay? So, sine 50 is approximately 0.77. Sine of 410 degrees, if you're going to use our calculator, this is still 0.77. So, it seems like not only once again, these angles are coterminal to each other, but they also have the same value. Okay? So, as we find the value of the two given coterminal angles, the answer is the same, right? They are in fact the same, just like this one in case. Just like this one, for instance. Therefore, that function, sine function to be particular, is periodic. Sine sine could be a periodic function. Now, the thing is, what is periodic? Okay, or how would you know if a function itself is periodic? So, we're going to talk about it here. Function is periodic if function of alpha plus a is equal to f of alpha, where alpha is the angle and a is a real number. Okay? So let's just say, for instance, let's just say I have sine of 60 degrees. Okay? Now, remember that just like earlier, oh wait, hold on. Just like earlier, like what we did here, we actually get its coterminal by adding 360, right? So let's try adding 60 degrees by 360. And let's take a look if they are the same. Just like what we did in our previous examples. So 360 plus 60. Okay. What is sine 60 degrees? It is square root of 3 all over 2. This one, 60 plus 360, it's actually 420 degrees. And if you're going to get the angle in this case, this is actually also square root of 3 all over 2. Wow. It seems like, yeah, we can use other number, then we can use also, what, 360 degrees? You get, what I'm trying to say is that seems like not only that we have an angle here, okay, and on the right side, we have an angle here, but we use 360 degrees here to add with this angle, which as a result, it's 420 degrees. And you see, despite how different they are, even if they are coterminal to each other, they have the same answer. Okay? So therefore, we can say that sine theta is equal to sine of theta plus 360 degrees. We can say that sine theta is equal to sine of theta plus 360 degrees. All right? This one is very useful if, for example, you're having a hard time in getting the value of a sine function where where the input is, let's just say, bigger than 360 degrees or less than 360 degrees. For example, sine of 450 degrees. Okay? This one, if you know how to get the value of sine, but you are only used to evaluating the sine where the angles are from 0 degrees to 360 degrees, then you would be having a hard time to solve this one. So what we're going to do here is let's just assume that this one is a sum of a given angle and 360 degrees. So basically, what number that if I'm going to add it with 360 degrees, the answer is 450 degrees. It's actually 90 degrees. So we can have sine of 90 degrees plus 360 degrees. Okay? Then, what you think that this number, if you're going to add it with 360 degrees, would result to 450 degrees, we can just use that angle instead, which is 90 degrees. So therefore, instead of just using sine 450 degrees, we can just use sine 90 degrees. Oh, see? See, it's simple, right? That's it. So here, if ever you're having a hard time, think of it like this way. Think of what angle that you can use. I mean, think of sorry. Think of an angle that if you're going to add with 360 degrees, the answer is 450 degrees, which is this one, right? And what angle that you think of, you will use it here instead. So what is sine 90 degrees? It's actually 1. Now, can we prove it here? What is sine of 45 degrees? 450 degrees, I mean. It's still 1. Oh, you see? Now, how about other trigonometric functions? Well, we have cosine. So cosine theta is also equal. Oh no, sorry, that sounds wrong. Cosine theta is equal to cosine of theta plus 360 degrees. So if you're asking me what would be the explanation here on why cosine theta is equal to this one, it's just the same as how I explained sine theta. Okay? Same explanation. Okay? So let me give you an example. So we have cosine of, suppose we have no, wait, no, not at 45 degrees. Let's just say, hmm, 60 degrees. Right, 60 degrees. Here, according here, we can have cosine of theta plus 360 degrees. So cosine of 300 and, oh wait, no. Sorry. I actually forgot the angle here, which is 60 degrees plus 360 degrees. There we go. So cosine of 60 degrees, the answer here actually is 1/2. And here, if we're going to add 60 by 360, we have 420 degrees. So here, this is actually also 1/2. Okay? And the rest is history because the way how I explain why sine theta is equal to sine theta plus 360 degrees is the same as the way how I'll be explaining why cosine theta is equal to cosine theta plus 360 degrees. Okay? So yeah, as you can see, uh, we have these two given uh, periodic properties of trigonometric function. Actually, there are other functions as well that has this type of property. So if you would observe here in sine and cosine, if ever we have this graph, and suppose we have a given angle, right? And then we added by 360 degrees. What happens is just like what I explained earlier. If, for example, we have this given angle, if you add it with 360 degrees, you're going to revolve or rotate once more because you add 360 degrees, right? So as you can see, they're in the same place. Okay. So it's basically explains the periodic property of sine and cosine. Okay. If you're going to find the sine or cosine with a given angle here, and that given angle that you're going to use here will be add by 360 degrees, what happens is that the you're going to revolve once more. And the thing is, they're in the same position, which in fact they are coterminal to each other, right? But there's one thing, one function um, that is unique to sine and cosine, which is this one, tangent theta. Tangent theta is equal to tangent of theta plus 180 degrees. Why is it 180 degrees but not 360 degrees? You know? So you see, these two, they are actually related to coterminal angles because as you can see, just like what I explained here, okay, so here, if you're going to get the coterminal angle, we have a revolution here, which is, yeah, a revolution here at the same place. So, yeah, that's basically how we get the periodic property because even if we get its coterminal angle, the answer would be the same. It's what will be the value here initially that would be the same value as in this place. See, that's it. That's it. But why here in this case 180 degrees? So here's the thing. This 360 degrees, the reason why the reason why the angle here is the same as sorry, the value here is the same as the value here. It's because of 360 degrees, right? Similarly, I mean, uh, the same thing here as cosine. What will be the value here for cosine? That's the same thing as well here in this case, as long as it's 360 degrees. Because if you use different angle, like let's just say 180 degree, the answer on the left and on the right will not be the same. Hence, the equation is not satisfied. So this 360 degrees is the reason why both of the equations are the same. So this 360 degrees is what you call as the period. Okay? This is your period. Number here, this real number, this A here, that is actually your period. The reason why both of them are actually the same. Okay? But there's actually more explanation of what really is period. Okay? In this case, this is actually period. The reason why both of the sides are equal to each other. But there's more than that. We will discuss that on the graphing of trigonometric function. Here, on the other hand, the period here is 180 degrees. But why not 360 degrees? Let's try to have some example, okay? Tangent of 60 degrees. Remember that tangent here is theta plus 180. So let's just say we have 60 degrees plus 180 degrees. So 60 degrees plus 180 degrees, I do believe it's 210 degrees. Am I right? 60 plus 210. Or maybe it's 240. Oh, it's actually 270. 270 degrees. Okay. So, what is tangent of 60 degrees? Tangent of 60 degrees, it's actually square root of 3. And tangent of 270 degrees is also square root of 3. Okay, so we can say that they're the same. All right. How about we try other, how about we try 360 degrees? So 60 degrees is equal to tangent of 60 degrees plus 360. What would be the result here? So 60 plus 360 is actually tangent of 420 degrees. So what is tangent of 60 degrees? It's square root of 3. And tangent of 420 degrees, it's also square root of 3. So why 180 when we can have 360 degrees, right? Because again, I told you the period is the reason why the left side here is the same as on the right side. Okay, because without it, the equation will not be satisfied and the equation will never be periodic. However, in this case, you see, we try 180 and then here we have 360. The results are in fact the same. Therefore, why is it 180 degrees? Why not 360 degrees? Just like from the previous trigonometric function that we discussed. It's actually simple, all right? Here, I'm going to explain it to you. We have a graph here. Then suppose we have a given angle here. So here, okay. So for the sine and cosine, we get its coterminal angle by adding 360 degrees. Tangent, on the other hand, it's not about 360 degrees. Actually, this is actually more on the line itself. It's actually more on the line. Now, the question is, why do we relate line here? Because tangent is actually another type of line. Tangent is another type of line actually. And remember that in a line, it passes only through one point. So that's like, yeah, that's like the additional information about tangent, but yeah, that still explains why 180 degrees. Think of it this way. We have two conjoined, if I'm correct. If it's conjoined is the correct way to describe this one. Let's just say we have two conjoined lines, okay? Or rather a line that connects at a common point, or they have a common point rather. And then let's just say that in the between the two, you will form a line. Actually, I explain like how would an angle form? Okay, how would an angle form, right? Or what is the definition of the angle? I actually explained that like on the first three videos about what is an angle, basically. So in here, you can form an angle here because you have two lines or rays rather that are connected at one common point. So suppose you have an angle here, okay? So here we can assume that the angle here is obtuse because when the angle is obtuse, it's actually greater than 190 degrees, right? But less than 180 degrees. Now, what if, let's just say, this line and this line, they are perfectly aligned to each other, meaning they became like a straight line, just like this. Okay? So the angle here, if it's like perfectly a straight line, this is actually 180 degrees. So similarly, in this case, so this is a straight line, right? So if you're going to add 180 degrees by this angle, as a result, you'll be getting the opposite angle. Okay? And not only that, but you're going to have like a line here as well. So it is in fact perfectly straight line. So therefore, a tangent is equal to tangent of theta plus 180 degrees. But just like what I explained to the sine and cosine, okay, there is like a more explanation why 180 degrees is the period. Okay? So in the topic of graphing of trigonometric function, we're going to explain why 360 degrees is the period for sine and for cosine, and 180 degrees is for tangent. But for now, at least you know the idea of period. Okay? In this trigonometric function. Okay? So these are basically the explanations. Now, how about the others? Like cosecant, secant, and let's just say cotangent. Well, uh, for sine, the reciprocal of sine is cosecant theta. Okay? And what we have here that will be also the same for the cosecant theta. So that means cosecant theta is equal to cosecant of, wait, sorry, I forgot to put a parenthesis. Cosecant of theta plus 360 degrees. The reciprocal for cosine, which is secant theta, is equal to secant of theta plus 360 degrees. So basically, they're just the same as their reciprocals. Okay? And speaking of same as the reciprocals, that also goes the same thing for the reciprocal of tangent. So if tangent theta is equal to tangent of theta plus 180 degrees, then here we can also have its reciprocal, which is cotangent theta, is equal to cotangent of theta plus 180 degrees. That's it. Okay. So these are like the periodic property of trigonometric functions. So let's try to apply it in examples. Okay, let's try to apply that. Let's just say I have a number of let's just say I have sine of 405 degrees. Okay. So here, yeah, the number is bigger than 360 degrees or larger than 360 degrees rather. Now, we can apply this periodic property of trigonometric function. All right, just like what I explained earlier, we can use this one if ever we encounter a large number of angle, which is 360 which is greater than 360 degrees or less than 0 degrees. Okay, so here, let's try to think what what number or angle here that if I'm going to add 360 degrees, the answer would be 405 degrees. So here, it's actually 45 degrees. Okay? So meaning 45 degrees plus 360 degrees, the answer is 405 degrees. And what the angle that you think that if you're going to add with 360 degrees, it will result to 405 degrees, we can use that as our answer here, which is sine of 45 degrees. So that means sine of 45 degrees plus 360 degrees is equal to sine of 45 degrees. That's according to the periodic property of trigonometric function. Now, what would be the answer here? So sine of 45 degrees is square root of 2 all over 2. See? That's it. Okay. Now let's try another one. Okay, let's try another one. Let's just say that we have tangent of 540 degrees. So in here, we will do the same thing. But instead of 360 degrees, it's 180. So what angle that if you're going to add with 180, the answer is 540 degrees. So the answer here is 360 degrees. So we have tangent of 360 degrees plus 180 degrees. So the answer here, okay, since we think that 360 degrees, if we're going to add it with 180 degrees, will result to 540 degrees. Therefore, our answer would be 360 degrees. See? So with that, we can now we can now find the value here. Tangent of 360 degrees, actually it's 0. Am I right? Just making sure. Okay, tangent of 360, I 0. So the answer here is 0. See? Now let's try another one. Let's try like one last example. Let's just say we have cosine of cosine of, let's just say, the bigger one. Like let's make it bigger. 1080 degrees. Oh, how do you solve this one? Okay. So here's the thing. Okay? So the same technique. What angle that if I'm going to add it with 360 degrees, the answer would be 1080 degrees. So here, the answer would be what? 720 degrees. So 720 degrees plus 360 degrees. Okay? And what angle that we think of when we add it with 360 degrees, the answer is this one. That will be now our what? Our simplified answer, which is cosine of 720 degrees. See? It's based from this one. Okay? However, it's still big. It's still big, like big than, let's just say it's bigger than 360 degrees. So what are we going to do? Well, then let's do it the same thing. Let's do it continuously, right? 720 degrees. Okay. So what number that if I'm going to, I mean, what angle that if I'm going to add with 360 degrees, the answer is 720. So here it's actually 360 degrees. So cosine of 360 degrees plus what? 360 degrees. And what angle we use here? Think of what angle we use here, if we're going to add with 360 degrees that result to 720, that will be our answer, which is cosine of 360 degrees. So what is cosine of 360 degrees? It's 1. And we're done. That's it. Okay, that's it. Okay. So it's actually very useful. It's like it's similar on how would you get the coterminal angle. Okay. But it's I mean, yeah, it's similar that way. It's similar. It's just that for tangent, however, it's not 360, but it's 180. Actually, let's have one more example because I kept mentioning angle greater than 360 or less than 0 degrees, right? How about that? Okay, let's have one example. Let's just say we have a negative angle. Okay, we have that. So let's just say we have cosine of negative 330 degrees. Okay, that's it. Now, here, the same thing. Okay, what angle that if we're going to add it with 360 degrees, the result would be negative 330 degrees. Again, what angle that if I'm going to add with 360 degrees, the answer would be negative 330 degrees. So here, what, uh, wait, are you sure? Alright. In here, actually, we can have, first and foremost, wait. First and foremost, you might be thinking, I think it's negative 690, right? Cosine of negative 690 degrees plus 360 degrees, right? Right? I mean, yeah, it's correct, but we actually forgot something. And what's that? So here actually, I mean, we could do that, okay? We could do that. But remember even an odd function? Do you remember that? So if you're going to use even and odd function, what would be the result here? Remember that cosine of negative angle is equal to oh wait, no. That sounds wrong. Oh wait, correct. Cosine of negative angle is equal to cosine theta. Cosine negative theta is equal to cosine theta. So that means cosine of negative 330 degrees is just the same as cosine of 330 degrees. So what would be now our result here? Cosine of 330 degrees, it's square root of 3 all over 2. But how about we apply with periodic property? So remember, right, our angle that we're going to add with 360 degrees, the answer would be negative 330 degrees. The angle here is negative 690, right? Because negative 690 degrees plus 360 degrees, the answer would be negative 330 degrees. And just like what I said, in here, what angle that you thought of when you add with 360 degrees, the result would be this one. That would be our answer. Cosine of 690 degrees. Now, in here, we can apply even and odd function. We have a negative angle here. We can just instead exclude that or remove that. We will have cosine of 690 degrees. We can remove that negative angle. Remember, even an odd trigonometric function, if cosine of negative theta is given, then it is equal to cosine theta. Right? Now, the angle is big here, 690 degrees. Now, we can apply periodic property again. Okay? If I'm going to think of an angle where if I'm going to add it with 360 degrees, the result would be 690 degrees. That would be 330 degrees. So 330 degrees plus 360 degrees. Oh, that's it. Okay. So those are confused. What I did here is, right, we have 690. Now we will apply again periodic property. Okay. We will apply it again. So here, what angle, if I'm going to add with 360, the result is 690, which is 330, right? 330 plus 360 is 690. And since this is the angle that we thought of, we will use that as our simplified answer. Cosine of 330 degrees. So what is cosine of 330 degrees? It's actually square root of 3 all over 2. And we're done. Okay? These are like the examples for periodic property of trigonometric functions. Try the reciprocal functions like cosecant, secant, and cotangent. Okay? Then, yeah, try that on your own. Now, here, since we discussed the properties here, there will be no more practice involved, practice videos here because these are just like techniques or methods that you can apply to yourself and to the other problems. Because after this, we're going to discuss the application of the six trigonometric ratios, which is the angle of elevation and depression. So see you soon, guys.